Okay, so this is the PCB of our project. So essentially, right here we will have connectors, female connectors, and that's where we will pass in the current, and that current will then go to the Hall effect sensor. And these three right here are three concurrent channels that are all Hall effect sensors. Essentially, what that means is the current will go in and create a magnetic field through the Hall effect, and it will then output a certain voltage with respect to how much current is coming in. And these are all three 200 milliamps per volt, or 200 millivolts per amp.
All right, so after the signal goes through the Hall effect sensor and we get a certain voltage based on the current value and the sensitivity and the reference voltage, it then goes through a low pass filter, which is this over here. Essentially, you have a resistor over here and a capacitor over here. The low pass filter has a cutoff frequency of 50 kilohertz, which is supposed to be your bandwidth, and what is there essentially for us to cut out the noise and pass the signals that we want. And once that is done, it goes to the ADC here. As you can see, the three channels. So what this ADC does is essentially takes in that input voltage from the Hall effect and the low pass filter, and produces a certain digital signal based on that input and the reference voltage. And and that digital signal is then sent to the microcontroller.
So due to some last minute changes, we ended up using the microcontroller on the Arduino Uno to do what we needed to do. And what it does is it takes in the 12-bit signals coming from each of the analog to digital converters. It does some math to find out what the current is, and then it will output that current onto the LED display that we have.
The first two channels show 1 amp each, while the third channel shows half an amp. The first two channels take from a source of 2 amps split into half, while the third channel takes from a source of half an amp.